Okay, so we're going to learn a little bit about exponents so we can solve some equations. Up here, we were able to plug in values and get an answer, but sometimes we're going to have to solve those same equations, kind of like we did with the linear ones, when we were given the answer after so many years had passed, and we had to figure out how many years had passed, or how much was the original amount. So we're going to learn a few things first so that we can actually solve some of these equations. So we can undo exponents using something called a logarithm. So let's suppose we want to find log base 2 of 8. Let's look at what that actually is asking us to do. So to solve that, I'm going to use the draw feature. And when we are solving something like this, what we're going to do is we're going to put an x over on the right side. And what this really means is we're going to rewrite this as 2 raised to the x power equals 8. So 2 raised to the x power equals 8. Now if we stare at that and we think about what power do I have to raise 2 in order to get 8, well, let's think about it. 2 times 2 is 4, times 2 again is 8. So 2 times 2 times 2 is 8. 2 to the third is equal to 8. So our x here is a 3. So what the logarithm is doing is giving us the answer to exponents. So let's take a look at this one and see if we can figure it out. Put our x over here and use that circular rewrite. 3 to the x equals 81. So 3 to the x equals 81. So what I want to think about is how many times I've got to multiply 3 in order to get 81. Well, 3 times 3 is 9. Times 3 again is 27. Times 3 again is 81. So 3 times 3 times 3 times 3. 4 times. So x is 4. All right, well, let's do this one. Let's put an x over here. And we can go 4 to the x power equals 16. 4 to the x equals 16. Now, if we think about this, well, okay, 4 times 4 is equal to 16. I had to multiply 4 by itself twice. So x is 2. Now, we can do these right here without using a calculator. We just have to think about 2 to what power is equal to 8. But there are things we can't do without a calculator. For example, let me get out of the draw feature here. Well, it's not letting me escape. Maybe it will now. Let's see. Still won't. So sometimes logs don't have perfect answers, like this one here. Let's do that little circular rewrite we've been doing. Log base 8 of 50, and I'll use a different color here. So 8 to the x power equals 50. 8 to the x power equals 50. Now, if we think about this, well, 8 to the first power is 8, and 8 squared is 64. So this is somewhere between 1 and 2, but we don't know exactly what it is because it doesn't work out nicely. So that's why we need buttons on our calculator to do logarithms. Now, on our calculator, you'll have a button that has log. This is actually a base 10 logarithm. And you have a button that has ln. which is a base e logarithm. Now, we're not going to talk too much about base e at this point. We're just going to use the log button on our calculator to help us solve some equations. But before we use that log button, we're going to talk about some principles that we need to know. And for some reason, things are locking up on this page, so I'm going to open a new page. Hopefully, things won't lock up. All right, so first, I want to talk about a property of logs that we are going to use to help us solve. So let's say I have the log of x to the fifth. There is a property in logarithms that allows us to bring the exponent to the front of the logarithm, and we're going to use that property a lot. So in other words, I can take the 5 that is my exponent, and I can bring it to the front, and I end up with 5 log of x. So let's just practice that a little bit. Let's say I had 2 to the x, all right? And we're going to see things like that a lot. Well, according to this property, we are allowed to just bring that exponent out to the front. If I can get rid of the exponent, there we go. X log of 2. All right, now in this particular instance, because there's a number behind our log, we can actually find a decimal. So if I put log of 2 into my calculator, I hit the log button and put a 2 behind it, I get 0.3010. All right, now I can't do anything to the x, but I get x times that number. And if I wanted to, I can put 0.3010 in front of the x. All right, now let's see if I can go back to where I was. Oops, that's not it. I'm not sure if it's going to allow me to go down to these problems or not. So we're going to solve some equations that have exponents in them, and we're going to use the logarithm to solve them. So let's take a look at this first one. Now be careful, this is not 5,000 times x, it's 5,000 with x as its exponent. And when we see we've got exponents and we want to solve equations, we're going to use the log to help us solve. So what I'm going to do is I'm going to put a log in front of both sides of the equation. And I'm not sure if it's going to allow me. I may have to, let me just rewrite the equation over here since it's being ornery. So I have 5,000 to the x equals 20,000. And what I'm going to do to solve it, since I noticed that it has an exponent, is I'm going to use a log. So I'm going to put a log on both sides. Logs always go in the front of whatever they're applied to. So this log is applied to the 5,000 over x, and this log is applied to the 20,000. All right, now on the right side, I'm going to use that little principle that we were just talking about, where we take the x, or the exponent, and we pull it out to the front of the logarithm. So I'll get x log 5,000. And the exponent is no longer there. It's now in front of the logarithm. And then over here, I still have log of 20,000. Now that I've got the exponent out of there, I can just use my calculator to find these two logarithms. All right, so let's put log of 5,000 into our calculator. And I get 3.69897. And then I'll put log of 20,000 into my calculator. And I get 4.30103. And with these logs, it's very wise to take them out several decimal places so that you don't get an inaccurate answer. All right, now let's really notice that this is just a number being multiplied times x. Normally, we would have that number in front of x, but it doesn't really matter. It means the same thing. So let's just divide it out to get x by itself. And then it's really just a matter of putting this right-hand side into the calculator and seeing what x is. So 4.30103 divided by 3.69857 gives me 1.163. We'll just round it off to 3 decimal places.